Shall we go for looking for problems? Okay. Suppose the regular expression A star A plus AB. This is a regular expression. This particular Kleene's theorem helps you to convert. See, what was the statement of Kleene's theorem? Anybody remember what Kleene's theorem is? Anybody can repeat it? Please look at the Kleene's theorem. The statement of Kleene's theorem. For the proof for which we have done the proof. Yes?
Every regular language is accepted by finite automata.
Okay, these proofs, after this proof statement, one Kleene's theorem we have. These are the statements. What we proved?
The regular language can be proved by the transition table.
No, उसके बाद करें. For any regular expression R with regular set LR or sigma, there exists a NDFA with null moves. Okay? So, what it said, in short, what it says that for any regular expression, the equivalent NDFA with null move is there. There exists. That we exactly prove. For every regular expression, for example, the example regular expression here we have taken. Sit down, please. For this regular expression, there is a NDFA with null move. Okay? So how to have a NDFA with null moves, that exactly we have seen in during the proof of Kleene's theorem. So what we do, we just convert, we just see how we can have a NDFA with null moves by having this regular expression. So in examination, you will be asked a question like this. For the following regular expression, draw NDFA with null moves. This is the university exam question. So the regular expression will be, for example, like this: A star A plus AB. So you are supposed to draw a NDFA with null moves for this regular expression. So in short, what we can say, this Kleen theorem gives us a method to convert a regular expression to NDFA with null moves. Okay? We will see how can we go for conversion. First of all, separate the regular expression. How do you separate this? A star and there is a concatenation is there. In this part of, this is the one part and this is another part. In two different parts we can divide this regular expression. Okay? Any other way we can divide it? Can we divide A and star and A plus AB? Can we do three parts like this? Can we do it? कर सकते हैं क्या? So at the point here, because here this particular, this is one entity, I cannot divide at the first moment. So at this moment I can have two divisions. So steps to convert RE to NDFA with null moves. Okay? Step 1. Divide, please note down, regular expression in part. Okay, parallelly I will do it at this side of the board. First of all, for A star and A plus AB, these are the two parts I have for this regular expression. So next we need to draw the equivalent automata for individual parts of regular expression. Second step, draw the finite automata, okay, for individual part of regular expression by applying Kleene's theorem. So I will draw it. For A star, I am having A star. How do I draw a regular expression for this A star? I had like this. For closure, I had a regular expression like this. R star in the derivation, in the proof, I had a regular expression for Rn star. कैसे था वो? This way. This is the initial state. So this way, I had a regular expression. Do you remember? All the transitions were done. For Ra star, replace this Rn by A. It becomes A star. So what is the regular finite automata for A star? Just replace by this. This is basically Rn star. This is basically Rn. Regular expression. This is not a regular Rn. This is a FA for Rn. Finite automata. This is the part finite automata for a regular expression of length n. So this regular expression, okay. For this regular expression, this is the finite automata, and for Rn star, okay, this is whole is a FA Rn star. This is a finite automata for this much. What this whole arrangement you can see as a finite automata for Rn star. Do you understand? So here I want to have a automata for A star. So how should I do that? I can keep all these things as it is. Only what Rn is that what is the Rn? That Rn I have to replace by A. Okay? So see how can I have? So this A, this I will replace. This is the regular expression A. Okay, and this is a automata for this is a Rn, and Rn is equal to what? A. So I prepare a loop. Since it is a closure, A star is a closure, I do have a loop like this, and I will add an initial state and a final state with null. And I remove this. I will say this as A, and for A itself, I can draw a finite automata. For A, what is the finite automata? I know what is the finite automata for A. This is the finite automata for A. Okay? So this much arrangement is a what you can say finite automata for A star. So if I look at this, I can able to some of the nulls from this diagram of automata are unnecessary. This particular automata we prepared as per the Kleene's theorem said, but I clearly see that some of the transitions are unnecessary. Null transitions are unnecessary. I can remove this. Okay? Getting? So I can also merge this and this into a single entity. So first of all, I can merge this. So how can I get it? If I merge this and this, what happens? And the key. So if I merge this, so what I get? Can I get this kind of transition? Okay. Finally, the remainder is what? This much. Okay. So again, I consider this is at this moment. This is what the finite automata for A star. In further step, we will see how to again minimize this. Okay. So this is a equivalent regular expression. Finite automata for regular expression A star. Then further we should go for A plus AB. How can we go for A plus AB? I remove this. A is again, this part is again can be divided into two parts. What? A and AB. This is A plus AB. Basically, this is one part we can consider. So these two regular expression A and AB are operated over OR. Okay, this is in between this A and AB is OR. So we can consider this particular regular expression and can go for drawing a finite automata for Kleene's by using Kleene's theorem. So what? The concatenation part is also covered in case, which case?
Third case.
In case third. So I can consider this is a regular expression. What? Rn1 and this is Rn2. Okay? How we draw the finite automata for Rn1 plus Rn2 during the proof of Kleene's theorem? कैसे बनाया था? This was the diagram. See initial state, final state. This is for Rn1, for Rn2. This is the initial state. This is the final state. So since these two regular expressions are combined by OR operation, we had a parallel lines and these both were connected. The start state of Rn1 and start state of Rn2, we were tied with a start state, and the final state of Rn1 and final state of Rn2 we tied together with final state. And all these transitions we consider as a null. Okay? Case 3. Exactly by using the same method, we can go for drawing a finite automata for A plus AB. So what I can do here? I can replace this by A. Okay? Rn1 is A, and this Rn2 I can replace by A B. And this particular automata now it becomes what? For FA for A plus AB. FA for regular expression A plus AB. Okay? Right now we are having the partial automata for the part of regular expression A star and A plus AB. And these two are, we can see that these two are concatenated. So we are having a regular expression. We are having what? The proof. We are having the method to concate. How to concate the two regular expression in Kleene's theorem. In which case? There is no case considered for this. Okay, so one more case you can have. So for concatenation purpose, okay, you have taken this particular diagram. Do you remember this diagram? Because I am going to erase it. At the end, during construction of the total finite automata, during the construction of total finite automata, I am going to consider these two diagrams. Right now, do you remember that? Okay, I am going to see. मुझे क्या करना है अभी? ये दोनों को अटैच करना है, दोनों को कॉन्कैट करना है. A star is concatenated with this particular A plus AB star, AB. So this is the finite automata for A star. This is the finite automata for A plus AB. I need to concat them. Okay? How do I concat? My total regular expression is like this: A star A plus AB. This is what I consider Rn1. This is I can consider Rn2. Okay? So in between these two, the concatenation is there. Dot. And so how can I have a equivalent regular expression for automata for this? Initial state, final state. This is from Rn1. I can have voice. I can have another part Rn, the second part of finite automata, Rn2, initial state, final state. So now at this moment these two are separate. Okay? I want to connect them by concatenation. How do I concat these two different finite automata? I want to concat them. कैसे concat करेंगे? जोड़ना है. How do I join them? For plus operator, what we are doing? How we are doing with plus? We had a parallel lines, parallel. Okay, but during concatenation, how do we concat these two? It's very simple. The final state of Rn1 you connect with the initial state of Rn2 with null moves. It is connected now. Getting? The initial state, you introduce one start state, one final state, okay, and connect the start state of newly introduced start state to the start state of Rn1. And the final state of Rn2 you connect with the newly introduced final state by null moves. So here also null. So this is the way we connected two finite automata, bar and operator. Okay? So exactly similar way we had two finite automata. What was the finite automata we had? This finite automata. Okay? So what was the equivalent automata for this regular expression A star? Initial state, final state. Okay? And finite automata for A plus AB कैसे था? A B. So we had connected. This is with start state. We connected these two with final state. These were the two finite automata. Okay? इससे पहले बनाए थे हम लोगों ने. Do you remember? So now exactly what it is said in Kleene's theorem. If you want to connect the two regular expression, and that is by connected by AND operator, then what you need to do? This is, if I consider this as a Rn1, I can name this as a Rn1, I can name this as a Rn2, just like this. Here Rn1 means this one, Rn2 means this one in your case. Stand up. Do you want to go outside? Please come out. Come out. Please come out and go outside. Come out. Just please come out. I say come out. Don't you understand? Please come. Please come. So what it is said in Kleene's theorem, if you want to connect two automatas, final state of Rn1, you need to connect with the initial state of Rn2. Okay? So do the same. What is the final state of Rn1? What is the final state of Rn1? This is the final state of Rn1. Then you connect with the initial state of Rn2. This is the initial state of Rn2. Connected by null nodes. I can indicate by some display. Okay? After that, what it is said? Introduce new state, that is a initial state, one initial state and one final state. Okay? So I will introduce it. I introduced, this is a initial state. I introduce one of a final state. What do? I connect newly introduced initial state with the initial state of what? Rn1. In our case, the initial state of Rn1 is this one. Okay? By a null transition. And here it is, obviously it is in null. Here it is null. Here the transitions are also null. And what is next? What is next? What to do with final state?
Final state, new final state.
Yes. Connect newly introduced final state. Okay? How do we connect? Connect the final state of Rn2 with the newly introduced final state by null. So this total finite automata, this is the automata for what? For the regular expression A star A plus A. This is a finite automata and this is what? This is a NDFA. Is it a DFA or NDFA? Is it a DFA or NDFA? How you say it is a NDFA? Why are you coming? You stay outside. How you say it is a NDFA? Listen. How do you say it is a NDFA? कहीं से आपको लग रहा है कि एक इनिशियल स्टेट से फ्रॉम a particular state say more than one transition you are having for a single input? From this particular state there is only null. This is null. From this A and null. From this null. From this one and null and null. Yes, it is now a NDFA. You see this from this particular state you are having two nulls. This is kind of a non-deterministic property we are having. So that is why this is a NDFA. with null moves. Keep quiet. Prepare. So these are the two steps only. Convert the regular expression to NDFA with null moves. So for this particular regular expression, we have prepared a NDFA with null moves by using Kleene's theorem. Okay. One more third step is there. Simplify resultant NDFA with null moves as much as possible. As much as possible. So, as much as possible word is not clear, huh? But through this example, we will try to understand how much we can make minimize. So here you can see clearly. I started with this is start state, and with null I am coming to this particular state. Okay, and from null again I am reaching to this state. So by having two nulls, I am reaching to this particular state. So this null is basically equal to null. So why do you have the two null moves? Can we replace these two null by one null? Is it possible? If it is possible, remove that. Can I remove that? Can I remove this null? Okay? Yes, I can remove. So null is considered. And further, can I remove this null? These two nulls? No, these are parallels, okay? They are not series. So I can have this way. So since these two states are final state, now this is the final state, this is the final state, and I can merge these two by removing this null. So I finally consider this is a final state. So by applying the possible minimization, I am able to have this kind of analysis. Okay? So these three steps you have to follow when you are asked to convert a regular expression into a finite automata. Further, this is a finite automata, and next step is to basically this finite automata is having something null within it, embedded. So nulls are not good for us. Okay? So to say a particular finite automata, it is having no nulls. It should not have any nulls. So further, we will go for looking for a procedure to remove these nulls from this finite automata. Okay? So next discussion will be removing null transition from NDFA. Okay? Removing null transition from NDFA. This is the next part we will Consider. After this, after removing all null transition, we will get NDFA. But NDFA again, it is not a finite automata which is required. We want to have this NDFA is something non-deterministic. Okay? So that non-deterministic part we can remove from this NDFA and we can have a DFA, deterministic finite automata. So after that, we will see the conversion of NDFA to DFA. Okay? So further, DFA will have some unnecessary, after conversion of NDFA to DFA will have something extra states within it which are unnecessary. So the number of states we can minimize from a DFA. Okay? And this after we can minimize the number of states from a DFA, and we can at the end we can have a finite automata, optimized finite automata, which is the best design for a particular regular expression. Okay? So the third part we will discuss minimization of DFA. So in examination you will have a simple question, the questions over all these points. You may have question like this. Remove null transition for the given NDFA with null moves. So you will be given by a NDFA with null moves and will be asked to remove all null moves. That is a question. Okay? After that, you will be given by a NDFA. Okay? And you will be asked to convert it to DFA for 6 or 8 marks, which is very, very simple. All these procedures are very simple. Another question you may have, you will be given by a DFA and you will be asked to minimize the number of steps. Okay? Do you understand? So first of all, see, this is the step from after giving a regular expression, we came to this step where we had a NDFA with null moves. Okay? By having that NDFA, we need to remove the null transition. We will get NDFA. So from NDFA, we need to convert DFA, and from DFA, we need to minimize the number of steps. Okay? Right now, we are at this moment where we just converted given regular expression into a NDFA with null moves. To practicize it, I will give you a problem, and he being here only, you will work out it. A plus A star AB plus B star. Convert this regular expression into a NDFA with null moves as per the procedure to discuss right now. So this is a very simple. Once you find a good hand by practicing this, you can draw the finite automata for any given regular expression within one step. Okay? एक step में आ जाता है, but you need practice for that. नहीं, वो सब बनाना नहीं है आपको. Just do it directly. You are only needed to apply the Kleene's theorem for this. मैं आपको ऐसे डायग्राम बना के दिखाया आपको. I shown this kind of general diagram to work out, to apply the Kleene's theorem. You can do it directly. Like so for this is the finite automata for A. Next, after that plus is there, means I can have A star and AB. Okay? This is A. This is state A star, A, B. Next plus is there. So B star. Or what? Or plus मतलब parallel करना. You have to consider it as a parallel. This or this or this. Okay? So how do we have? You have to consider the initial state here, the final state here, and you just connect all the state by null transition and consider this as a initial state. And combine all these in parallel with the final state. Null. This is equivalent to what? A. This is parallel with this means what? Plus. And what is this? A star, AB. Okay? The brackets are not significant here. AB or AB bracket into bracket both are same. I can consider AB bracket and plus what plus? B star. This way you can have a equivalent NDFA with null moves for a given regular expression. So by having this kind of direct method, shortcut method, you can move on. And I will ask you now to prepare yourself a regular expression. A plus B star, A plus B whole star AB. Sit down. We have a finite automata NDFA with null moves for the given regular expression. See, the simple thing is what? Wherever you find plus, do a pair. Okay? Wherever you find ending means dot operator means ending between A, B like, so do the series connection. And if you are having a star, then do a loop. Star means what? Closure means looping. B star को loop करो. एचा आहे ना, एच कुठं आहे, हे त्याचं प्लस आहे, बीचा स्टार आणि त्याचं कॉन्कॅटिनेशन काय, ए प्लस बी करा, ए प्लस बी आहे तिथे, त्याला कनेक्ट करा. आता काय हे काय झालं, बी स्टार ए प्लस बी, बरोबर, आणि ह्याचा स्टार करायचा आहे. स्टार्ट करण्यासाठी आपलं आहे की स्टार्ट करण्यासाठी याला लूप करायला पाहिजे. सिंपल, दिस रूल यू ऑलवेज रिमेंबर. दिस बिकम्स ए स्टार ऑफ दिस. काही असो, काही असो, आता इथं तुमचे काही करू त्यासाठी डेव्हलपमेंट त्यांना स्टार्ट घ्या ना, कुठे स्टेप आहे, ए और बी आहे, बी स्टार ए स्टार. आता ह्याला हे तुमचं काय झालं, हे डेव्हलपमेंट ओके. इसको क्या करना है, स्टार introduce this or to have a rule, take this, correct, start with okay, and remaining is what will be simple. Okay. Next is plus means parallel automata you can have. So that is B star A plus B, that is again or okay. So this whole is star. I directly have put A and B. What you can have? You can have this way. This way also you can have. Both are there. This is, and this I needed to make a loop. So how I can have? I introduce one state and make a looping with null moves. This becomes now B star A plus B whole star. This whole element is equal to no loop. Here in this case only B is looping. Okay, B star plus A plus B star and A plus B, that we are making to revolve, closure. Okay, so then AB, this is connected with this null, one null you can have here, A, B. Okay, the last part. So these are the two parts here I am having. So I need to connect them by introducing new state and final state. So this state, since these are R, this or this, I again have a parallel lines this way, and this and this. This way I can finally come up with the finite automata. This is a NDFA with null moves. So if possible, if there is a possibility of removal of any state, any null transition, you can remove. Otherwise, you can keep it as it is. There is no difficulty. So if you go on removing null excessively, you may make mistakes. Okay, we change the meaning of the finite automata. So if it is possible to remove, then only remove. Otherwise, keep as it is. Okay. So in the next section, we are going to discuss the method. How can we remove the null from the given NDFA with null? Okay.